Let's get started. Okay, can you all see my screen? Okay. So yeah, today we will be looking at arrays and we will be looking at input-output redirection. We'll be looking at common mistakes you can make in your programs using arrays. Then we'll look at some random number generator code and some other discussion. So let's start with arrays. So we'll start slowly and we'll look at how to reverse a given array. So let's say this is a program with the array has 1, 2, 3, 4. So initially to print this, we are going from 0 to size, and then we are printing the elements in the array. And then to print it in the reverse direction, we start from size minus 1, and then we are decrementing I all the way to 0, and then we print the entry of array. So if we run this, yeah, so it first prints the array in the forward direction, then it prints it in the reverse direction. So I hope this should be clear. Okay, so last time when we were discussing decimal to binary conversion and all that, so I think there was a question on can we do this in code? So now that we have learned arrays, we can try to do it. So let me uh, code it up. So let's see. So let's say we have a main function. We have int number and a base. To give a so we are asking them to give us a number and give us a base in which we want to convert. So remember the algorithm, right? So what was the algorithm? So when if we have to convert 10, what do we do, right? So we divide 10 by 2 and we get a 0 and 5. Then we divide 5 by 2. Then we get 1 and 2. Then we divide 2 by 2 and we get 1 and sorry 0 and 1. So I'm writing remainder and quotient, and then when I divide 1 by 2 I get 1 and 0, and then I basically print it in the reverse direction. So the 10 is basically, if I print this in the reverse direction, it's 1 0 1 0. Is this correct? 8 plus 2, yeah. So um, are there any questions? Like this is what we discussed in the last help session as well. Okay, I assume there are no questions and I assume I'm still audible. So yeah, let's try to write this in code. So basically what are we doing, right? So we are every time we are dividing the number with base until it goes down to 0. So we can say keep doing something until n is greater than 0. And we want to store this remainder somewhere, right? So how about we store it in an array, and let's say the array is of size 100. So every time we divide this number by base and we store the remainder in array and we change the number to the quotient. So basically so I'm going to store the remainder in the array, right? This is the remainder of dividing n by base. and I will change n to the quotient. And this will keep doing this uh, until n is 0. So then what do we have to do? We just have to print this array in the reverse order, right? So we already looked at the code on how to print array in reverse direction. So we just write that down. And printf. Okay, let's see if so we are we want to convert 10 to base 2, and yeah, indeed it shows 1010. Let's try to convert 15 to base 2, and it shows 1111. Let's try to convert 15 to base 8, and it shows 17. So that is also correct, 8 plus 7. And yeah, we can do it for bigger numbers. 255 is all ones. 1 2 3 4 8 ones. Yeah. So the algorithm we had discussed last time, we just implemented it using arrays. And the good thing about this implementation is you can pretty much convert it into any base, right? So I can convert this into base 3, and this will show me which like the conversion in that base. So if we convert 10, so 10 is 9 plus 1, so that is 3 square plus 1, so that is 101. If I convert 8 to base 3, that is 2, so that is basically 2 times 3 plus 2, 6 plus 2 is 8. I hope you are all with me so far. So what about base 16, right? So if I convert it to base 16, it prints 1515. So we would like to change it to ABCD. So this should have been FF instead of 1515. So anyone has any thoughts like how to print FF? Basically how to support base 16 here in this code.
I think we need to make some if conditions.
We can put if condition.
Sir.
Yeah,
Sir, we can define all digits from 0 to F first and then choose them based on what is the base.
right. Yeah, so that is one way, right? So basically we build something like a lookup table. So if it is 0, then we print 0. If it is 15, we print F. And so you can build like arbitrarily large lookup table.
Sir, we can do minus 10 plus 65 and in print it in char.
Yeah, so that is one approach as well. So if we say if age is less than 10, then just print age. Otherwise, we will print character A plus, so we will print a character AJ minus 10, right? So if I run this,
So we can use %x in printf.
Yeah, let's try that too. So yeah, we can try that too. So now 255 in 16 is FF. So another approach is we can do. So what is the approach? So I don't know if this will work. Let's try it. So the suggestion is use %x. Is that correct? Okay, let's try it. Okay, great. It actually works. Yeah, so again, like, so this is good, like, but in general, if you have larger bases, then what happened? So 17, let's see. So 250, okay, what is 17 square? 289. So if I try to print 288 in base 17, yeah, so that is the problem with %x. It turned it into 1010, right? Because in base 16, we only have till f. But if we go to the older code, so again, this older code as well will break down at some point, but it will support higher bases. So when we go to 288, it prints GG. So in base 17, G means 16. So this is 16 times 17 plus 16, which is basic, which should be 288. Yeah. Cool. So any questions with this? This is a decently big program with arrays.
Sir, can you explain how is a plus aj minus 10 that gives us like character? I mean, how the same character which you want?
Yeah. So basically, what do we want, right? So we want for 10, it should print A, right? For 11, it should print B. For 12, we should print C.
Yeah, okay, I get it.
Okay, cool. Great. Okay, so let's go back to the reversing program. So in this program, we were defining array upfront, right? So we had defined array as 1, 2, 3, 4. But what we can do is we can always also take the input from the user. So we can say, okay, instead of defining it upfront, I'm saying there's an array and I'm asking user to give, I think we looked at it in the lecture as well. So keep giving me inputs until the array until the input is 0, and then I'll print it in reverse. So if I run this, and if I give it 1, 2, 3, 4, 0, then it will basically print it in reverse until I give it 0. So another thing we looked at in lecture as well was, so every time you are writing code, right, your code may not work in the first shot. So giving this input every time can be tedious. So for that, what you can do is you can put the input in a file. So let's say I open this input file and I put 1, 2, 3, 0, like 4, 0 in here. Then I can run the same program and redirect this input. So I'm saying redirect input into a.out. And so this is same as giving this input on the command line. So as we can see, it prints the same output, right? And we can also redirect it and redirect the output into an output file using a greater than sign. So if I do this, then basically that output went to the out file. Any questions so far?
Sir, how does this I mean, how does this redirect command work? I mean, how it decide to go where it have to go?
Yeah, so basically, I think when you study more into computer science, like this is called shell, right? What we are at. So shell itself is a program written by someone. So everything you see on computer is basically a program similar to the one that we are writing together, right? So shell itself is a program, and when you, so this is a format of shell. So when you do less than, it interprets it as, okay, you want me to give this file as an input to this program. So there is no, it's just a shell's convention. Like it's potentially you could write a different shell which takes this input in a different way. But this is just a common convention in all the shell programs.
Okay, sir. Thank you.
Yeah.
So, sir, this was defined in the Linux. This is written in Linux, this code.
Correct.
Uh,
Yeah. 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 So underneath what it is doing is, if you want to get into more technical details, is basically everything is a file, right? So this is in is a file. So what they've done is basically your command line is also a file. So this is called std_in, standard input, and your output is called standard output. You also have something called standard error. So these are like three special files for the shell program. So generally programs take inputs from standard in and write outputs to standard out. But by doing this, you are redirecting, saying, okay, instead of standard in, take it from in, and instead of writing to standard out, write it to out. And standard error, we haven't looked at it, but in case you want to print out some errors, those go to standard error. Okay, so now let's do something interesting. So in is 1, 2, 3, 4, 0, right? What I can do is I can of course write a very large file, right? So this file has a lot of entries, right? So if I scroll down all the way to the bottom, this file has actually 595 lines. So let's see what happens if I give my program this in large, right? So I expect it should reverse the inputs. But if I run this, I get this weird thing, right? This is basically an error. And this error is called segmentation fault. So when you write array programs, you might run into this. So I'll just describe what they are. So basically what happened is, like, let's say this is a very simple program which shows two kinds of errors. So first of all, this array is of size 4, right? So it has 4 entries. In this first error, what we are doing is we are printing something beyond the size. So remember, your index go from 0 to size minus, right? So we are printing something. We are printing something beyond size -1. So we'll see what happens here. And then in this case, we are printing a very large value, like very large index in array. And we will see what happens in that case as well. So there are a bunch of warnings. It is telling us it is not correct to do all this, which is fine. So thank you, compiler, but we'll ignore those warnings and go ahead. So in the first case, what happened was, so when I did this, it printed a garbage value. I think you have seen garbage values in other contexts as well. So what happened was, since there is nothing after 4, so basically arrays are allocated as contiguous memory blocks. So it is saying that there are 4 blocks, and in first block there is 1, in second there is 2, 3, and 4. But what we try to do here is we try to print the starting, if it starts from 0, we try to print the 4th block of 4-byte addresses, right? But because there can be any arbitrary value in there, and actually if we run it multiple times, it will always print something different, right? It is always printing garbage value depending on what is after this 4, like 16 bytes, basically whatever is after that, it is printing that. So this can be garbage value. The other thing with this is so the way memory works is when you write this, it basically asks the OS to give me 16 bytes, right? And put 1, 2, 3, 4 in those 16 bytes. But when you try to index a large value, this actually may be some memory which your OS never gave you. So since you never asked for it and then you tried to access it, so it will give you something called a segmentation fault. So if you see segmentation fault in your programs, basically look for array indexes. They might be wrong, right? So these are two errors you need to be mindful about when you write array programs, like garbage values and segmentation faults. And they generally happen because we messed up the indexes in the arrays. So let's try to understand this reverse input code we were writing, right? So what it had was it had 100 entries, right? And then it said that I will keep taking entries until the value is 0, and then I'll try to reverse it. But what we did in the large input is basically instead of 100 entries, we gave it 595 entries, right? And so far there was no 0. The 0 came in the end of the file. So any idea how we can fix this program so that it doesn't crash? Or before that, do you follow what happened in like this error.c file?
Sir, we can add a condition to break if it reaches the size of the array.
Right. So yes, so what we can do is we can say if I is equal 100, I'll just break, right? I will not take more inputs. Okay, so if I run this, let's first try to run it on smaller programs. It works fine, smaller input. And if I run it on large input, it works okay as well. Like it doesn't wait all the way to 0. As soon as the array is filled up, it will just print the reverse. Okay, so I hope this is clear. Yeah, so this program looks very stupid, right? Like, yeah, like I know I won't make this mistake. But this is actually a very common error that happens when you're not careful. So look at this program, right? This program is basically just summing 5 numbers. So it is initializing array to 1, 2, 3, 4, 5, and it is looping on the array and taking a sum. And at the end of it, it is printing the sum. So we expect the sum to be 9, 12, 14, 15, right? But can anyone guess like what it will print?
Sir, it
Sir,
will print
I is
error.
less than or equal to size, so 10.
It will print 10. Okay. So someone said 10, someone noted that there's a equal to sign here. So that is a good, yeah, let's run this and see what happens. Yeah, so indeed, when we run this, it gives some garbage value. And that is because of this equal to sign. So basically in the sum, it is summing A0, A1, A2, all the way to A5. And because A5 is a garbage value, your sum will be messed up. Okay. So this is all I had for arrays. So before I move to random number programs, is there any thing which was not clear? No. Okay. Cool. So we'll look at some interesting things we can do with the random number generator, and specifically we'll design a rock, paper, scissors game. I don't know if you know about this, but so basically the way this game works is it's played between two players, and every player either chooses a rock, which is like this sign, right? And another player chooses paper, which is like this, and another player or so sorry, there are two players, so they can either choose a rock, which is this, paper, which is this, and scissor, which is like this, right? And the rules of the game are basically rock breaks scissor, paper wraps rock, and scissor cuts paper. Basically, if I do this and you do this, then this wins because rock will break scissor. If you do this and I do this, then you win because scissor cuts paper. And if you do paper, I do rock, then you win again because paper wraps rock. And if we both do rock, then it's a tie. If we both do scissor, then it's a tie. So what we'll do is code up this game quickly using random number generators. So to begin with, let's define what is a rock. Let's say rock is 0, paper is 1, scissor is 2, and then we'll ask the user to give us a, so user will give us an input, computer will, okay, let's say user will give us an input, so we'll say enter 0 for rock, 1 for paper, 2 for scissor, and we'll take their input. Right. So, and then if user is rock, I'll say right. So whatever they have given, we will.
Sir, I have a doubt. So
Yeah.
you have defined user as integer, and then condition is that user is equals to rock.
Yeah. So remember the.
So what is this hashtag define do?
Yeah, so this is basically a preprocessor, right? So what it does is before your compiler compiles, what it will do is it will look for rock and it will put 0 everywhere. So here it will put 0, here we'll put 1, and here it will put 2. So basically this line will be interpreted as if user equals 0. So these two lines are equivalent.
Sir, it hashtag define rock 0, then 0 value will be like a string or a integer.
Integer. So since we put it
I
as
mean,
if we did it like this, then I think it will go as string.
oh, okay.
Yeah, but we can try that. So we will try that. Okay, so user has chosen. Then we go and do let the computer pick as well. So for computer, instead of, so we can hard code something here, rock or something, but that makes the game very boring. So instead of that, we will just say we'll use the random function, and take a %3 because we want to generate values 0, 1 and 2, right? And then again, we will do the same thing. That computer right. So if this number is equal to rock, we'll print computer chose rock and so on. And finally, we have to decide who wins, right? So if user and computer are equal, then we print it as a draw. Right, so remember the rules, right? If both of them pick rock, then it is a draw. If user is rock, so if user is rock, there are two possibilities, that computer is either a paper or the only other possibility is computer is scissor, right? Because we already checked for user equals computer. So in this case, if user is rock, computer is paper, then we say you lose, otherwise you won, right? And similarly, we can handle other cases. When user is paper and computer is scissor, then computer wins. If user is scissor, if user is scissor and computer is rock, then computer wins, otherwise user wins. So what we can do also is this draw is, let's keep playing until someone wins. So we can wrap this whole thing in a while loop. Right, so we will wrap this whole thing in a while loop and we break out. In this case, we keep playing, otherwise we break out. Okay, so let's try to run this. So it did not like implicit declaration of function. I think I also need to include stdlib. Okay, let's play this. So enter 0 for rock, 1 for paper. Let's say I put in 0. Computer chose paper, so I lost. Damn. Okay, if I chose paper, then it is a draw and it is asking us to play again. So if I, let's say, pick scissor, then I won because computer chose paper.
So I think we should have time as run time so that every time different number is chosen by the computer.
Right. Yeah, you're moving ahead of me, but great. So yeah, like as you can see, the problem with this code, with this game is it's not fun, right? So I know first time it will basically, first time it chose paper. So I know it will choose paper. So if I just keep picking scissors, I will keep winning. Because I know computer will always choose paper the first time. So what I can do is, someone rightly pointed out, I should use srand with time. time is not declared.
That includes time protest library.
Right, so now this is truly random, so I don't know what computer is going to pick. So I chose paper and it chose paper again. So scissor, oh damn. Ah.
Sir, can you explain again why the previous script was not random?
Why the previous?
Why the previous choice of the computer was not that random?
Yeah, so basically the way, yeah, so actually let's look at it again. So I'm removing this srand function, right? And if I compile and run this. So before even running, I can tell you computer is going to pick paper. Let's see if that is the case. Yes, computer chose paper. So because of this, the game has become predictable because I was able to know what the computer is going to do, right? So I can just simply beat it by choosing scissor every time because I know computer will choose paper. So this was not truly random. So this is related to how this random number generator works. So basically in your computer programs, like your random number generator has two bits. So one is something that gives it randomness, so which is called seed, right? And you can seed it with a random value, which we are seeding it with the computer's time. So your computer programs are generally deterministic, right? So if I give it some input, it will provide some output. So the random number generators are a mixture of the two. We basically have a deterministic random number generator, pseudo, that's why it's called pseudo random number generator. And we have a non-deterministic or truly random seed. So by giving it that seed, you make it truly random. So, but if you don't give it that seed, it will take seed as 1 by default. So it will, since the rand part is predictable, it will always give the same output. So we can write a simpler program to see that behavior. Let's say right. So what I'm doing here is basically I am printing random number generators up to 100 from 0 to 99 10 times, right? So if I run this, so it printed 7, 49, 73 and so on. Now if I run this again, ideally I would want these numbers to change. But if I run this again, it prints the same output because we have not seeded it with a random number yet. So I can, if I go back to this code and if I just seed it with the time, then every time I run it, it will truly give me a different output, right? Because now that seed, every time I run it, since the time is different every time, the seed is different every time. So it is giving different output. So yeah, like actually this is a very interesting area. Like so like if you get into computer science research, this is something, this is a big problem in cryptography. like how do you come up with a truly random seed? So as you can see, even time is not truly random, right? So when I run this program, if I can know the time, I can sort of predict what this program will return, right? So for example, if I write another program, right? So now what I can do is let's say right. So if I print time first and then I print the random number. So if I know the seed to this random number, I can actually let's see if this works. Yeah, so since I printed the time, I know I can basically predict the entire sequence in which it will produce random numbers, right? So in our rock, paper, scissors game as well, for example, before running the game, if I can just print the time, then even before giving it rock, paper or scissors, I can write a separate program to run to figure out the random sequence that it is generating. Then I can again predict what the computer will choose, right, as rock, paper or scissors, because I am able to predict the random numbers that it will generate. So, okay, is this clear? I don't know if I lost you. Like what we did just now.
Excuse me, sir.
Yeah.
Sir, why
Even
are
if
we always
time
using
seed is
time zero? Can't we change the inner argument?
Can the seed itself be a time, sir?
Why are we always using zero? In place of zero, can't we use anything else?
We could. So that is not the main focus here. So I'll have to look at the time API. I don't remember what zero meant. Okay. So the API is basically, you can tell it, you can give it a pointer and it will store that time in that pointer. So by giving it null or zero, we are saying, okay, we don't care about storing it in here. You just return what the time is. So the main point is not that. The main point is basically your random number generators are a mixture of two things. So one is what is called the entropy part, which is something truly random. In this case, we are approximating that randomness with time. And then the second part is this deterministic random number generation. So once you seed it, the entire sequence will become deterministic. So every time you call land, you depending on the seed, it will generate that sequence. So the point I was making.
So that sequence will be same for every compiler. Shouldn't be, right?
No, shouldn't be. So the sequence can. So I think the sequence depends more on the OS part, or actually depends on the implementation of RAND inside stdlib, which is the library implementing RAND. But for a given computer, for a given your machine, your RAND should behave the same. Right? So if you run RAND from two different programs, they should behave the same. So basically the point I was making is the seed that you give should ideally be truly random, but in this course we will just approximate it with time because that is a good way of giving it random values. But in general, this can become a problem. And actually there is an interesting tidbit to share. So someone someone was running a lottery using this random number generator, and PhD from Stanford, she actually predicted that and was able to win lottery 4 times and win $20 million. So this is a this giving it a truly random seed is like a very important thing, because if someone can guess your seed, then the randomness is broken.
So sir, is it like legal to, I mean, she did not do anything wrong, right?
There is a lawsuit on her, and she's not. I don't know what is going on, but apparently she lives in. You can read this news article. I can post it. But yeah, she's not in jail yet. I don't know what is going to happen. But this is just, I think, from a CS point of view, this is just an example of why what we are studying matters. Yeah, so we built a very simple game, rock, paper, scissors, but sometimes sometimes there's a lot of money involved. So you don't want people to win your rock, paper, scissors. So yeah, how you generate random numbers is a important area. So I'll post these links. You can read this news, and you can also read about how Linux generates random number generators. So again, this is not part of the course or evaluation or anything. This is just to feed your curiosity. Okay, yeah, this is all I had for today.
So the number that are generated by the random generator operator, is it repeating or is it unique every time?
It may repeat after some point. So the guarantee it tries to provide you is basically so you are first year, right? Have you studied distributions, like probability distributions? Okay, so basically the guarantee it is trying to provide is the numbers that it generates are what is called uniformly distributed. So what that means is from 0 to rand max, every value is equally probable to come. So that is the thing it provides. So it might repeat, it may or may not repeat, but from a probability standpoint, every number has an equal probability. So when you play rock, paper, scissors game, you know it is equally likely to get rock, equally likely to get paper, and equally likely to get scissors. Like if there is some bias there, so for example, it is slightly more likely to get paper and slightly less likely to get rock, then someone can play this game a million times and make money out of it, right? Because they will have higher probability of winning and lower probability of losing if they bet on that. So what RAND provides is uniform probability distribution from 0 to rand max. I don't think it makes any guarantees about whether it can repeat or not, but yeah, it does provide you that uniform distribution thing. Okay, there are some comments. Instead of this, we can use condition user greater than computer and user less than computer. Yeah, so okay, let's try to simplify this program. I like it. So I find writing this very tedious as well. And I'm glad that you are finding it tedious too. So we have to write it this way currently because we have not learned functions. Some of this will become more cleaner once we learn functions. But let's see. So someone is basically saying that we can just use user less than computer. Let's see if that works. Right, so basically 0 wins from 2, 1 wins from 0, 2 wins from 1. So if I just do user greater than computer, it will work for this case, it will work for this case, but it will not work for this case, right? Because 0 actually wins from 2. Right. So any thoughts how we can make this cleaner instead of doing this if else, any thoughts what we can do here?
It is adding plus 2. I mean 0 plus 2 is 2 and 1 plus 2 we can view as 1, 2 and reverse 0. So we can do something like that.
So 2 is basically 0 plus 2. 0 is 1.
1 plus 2. I mean it repeats 1, 2 and again 0. Yeah.
And 1 is 2 plus 2 %3, right? So basically we came up with a formula. So basically all of them, like this right hand side here, you can derive it from the left hand side by adding 2 and taking a remainder from 3. Okay, great. So we can now clean this up and we can just say if user is computer plus 2 %3, then who wins? So user is this, right? So basically then you lose, otherwise you win. So this is a much smaller representation of the code that we wrote here, but it has its own pros and cons. Like it's a little bit less readable, so someone might get confused looking at it. But if you have these comments up here, it should be okay. So let's try to play this game. If I enter 0, computer chose paper, so I lose. Okay, so this is making sense. I chose paper, computer chose scissor. I chose scissor, computer chose paper. Yeah, so looks like that logic is correct. Yeah, so right. So with this, our program is much shorter.
Excuse me, sir.
Yeah.
Sir, the memory address of any variable, can we use that as a seed for the random function? So that and x that we store, then we can have n number of memory locations from the user's computer.
Yes, very beautiful point. Yes. So yeah, I think someone also had a comment saying, is it fundamentally impossible to generate truly random numbers? So I am not a cryptographer, so I think cryptographer might say yes to that, but from a practical standpoint, like we are able to generate random numbers, and lot of your computer systems, lot of things like passwords and lot of things depend on this generation of random numbers. So the way random numbers are generated in OS, which is the second link I'll share with you if you're interested, is looking at things that are going on in the computer, right? Because there are a lot of things that are going on in the computer at any point. So the OS looks at them and uses that as the seed. So basically it looks at inter key press timing. So the time it takes between pressing two different keys from the user varies from user to user, right? And varies from if I'm on a browser versus if I'm coding. So that time may vary. Similarly, the data that you are saving, the files you are saving, the stuff that is going to your disk has randomness inbuilt. Similarly, the stuff that is going out of network has randomness, right? So right now we are on a video call. So there is some randomness in the packets that are going in the video call, but after the class, I might do some browsing so that those packets will look very different from the current network transmission that is going on. So OS will basically provide these seeds to the programs. And those seeds are in like these special files inside OS, like dev random and dev urandom. So when I cat it, like, so this is OS provided randomness. Oh, this is crashing. Okay, that's me. Yeah. So basically this is OS provided randomness to your programs. So yeah. So time is not sufficient seed because people can predict time based on when you started the program. Sir, we are using the uniqueness of the user to generate random numbers. Yeah, so it's uniqueness of the user. It is uniqueness of what user is doing at a given point. And it is overall like your system is very random. So I have like sometimes Dropbox running. I don't have Dropbox running. So because of that, like my network traffic can be different. So they can be, it's not necessarily my own activity. Your programs on your system may be doing stuff without you knowing. So those can be utilized for randomness as well. Then the other comment was also very interesting. Why don't we use a pointer to do the seed for the randomness? So that has its own pros and cons. So I think when you study OS, if you study OS, there's something called, so previously that approach wouldn't have worked because previously in older machines, like if you just go 10 years ago, every time you have a pointer, it will always have the same value. And because of that, there were a lot of security attacks. But recently they added something called address space layout randomization. So now every time pointers have random values, but even those random values use the OS provided seeds. So it is better to just use those seeds. Again, I think this conversation has gotten much more advanced than I was hoping. And if you're lost in this conversation, it is totally okay. This is not supposed to be for 101.
Sir,
Yeah.
sir, I actually watched a video on YouTube once. They kept lots of lava lamps in a room, and they used to take pictures of them to generate random numbers, and
Yeah.
that helped in security of something.
Yeah, exactly. So you can use anything. So anything like physical events you can take which are unpredictable. So your CPU temperature is rising and dropping. All of these things can be accounted for and used as a seed. So again, I think this is a very interesting topic. I encourage you to read that article. But again, this is not part of the course. If you don't, it's totally okay. Yeah, but for our exercises, like we will just use time for now. Like if someone breaks our assignment and wins a rock, paper, scissors, it's okay. Like, so we'll just use time for now. Okay, great. Yeah, thanks for this very interesting discussion. Anything else? Cool. Yeah, so thanks everyone. I hope you learned stuff and I'll see you next week.
Sir, which paper are you talking about to read?
I'll share that article in a bit. These two articles.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you, sir.
Sir.